हेलो एवरीवन, मिशन फॉर एक्सीलेंस में आपका स्वागत है। आज हम करेंगे चेंज ऑफ स्केल प्रॉपर्टी ऑफ लैप्लेस ट्रांसफॉर्म। चेंज ऑफ स्केल का मतलब क्या है कि अगर हम t की जगह पे t का कोई भी मल्टीपल लेंगे तो उसका लैप्लेस ट्रांसफॉर्म क्या होगा। लेट अस डिफाइन द प्रॉपर्टी। इफ लैप्लेस ऑफ ft is given as fs, then Laplace transform of f of at will be 1 by a f of s by a. It means if we know the Laplace transform of ft, then we can find the Laplace transform of f of at. t का मल्टीपल अगर होगा तो जो पहले हमारे पास Laplace ट्रांसफॉर्म है उसको हम a से डिवाइड कर देंगे। Let us prove this property. So by the definition of Laplace transform, Laplace of f of at will be equal to 0 to infinity e raised to power minus st f of at dt. This is the basic definition of Laplace transform. Now, to solve the integral, let us put at equal to u. So let us put at equal to u. So from this, a dt will be equal to du. Now let us put all these values in the integral. So Laplace transform of a dt will be equal to du. So Laplace transform of f of at will be equal to 0 to infinity e raised to power minus s. Now value of t is u by a. S u by a, f of u, and dt is du by a. So now let us write this. Take 1 by a outside. 1 by a, 0 to infinity e raised to power minus s by a into u, fu du. This is nothing but Laplace transform 1 by a Laplace transform of fu, and s is replaced by s by a. It means we take it Laplace of fu when s is replaced by s by a. So we will write it as this is equal to 1 by a f of s by a. Hence we get Laplace transform of f of at as 1 by a f of s by a. This property is very useful in finding the Laplace transform of multiples of t. Now let us do an example of Laplace transform of piecewise continuous functions. Laplace transform of piecewise continuous functions. So first let us define this. Let us take one example. Let ft equal to e raised to power t if t lies between 0 and 1 and 0 if t is greater than 1. So this is piecewise continuous It has discontinuity at t equal to 1. So now we have to find out the Laplace of ft. So now let us take Laplace of ft. By the basic definition, Laplace of ft is integral 0 to infinity e raised to power minus st ft dt. Now this 0 to infinity interval is divided into two parts, 0 to 1 and 1 to infinity. So let us take this as 0 to 1 e raised to power minus st. In 0 to 1 function is e raised to power t dt plus 1 to infinity e raised to power minus st, and from 1 to infinity value of the function is 0. So now the integrand is 0, the second integral will be 0. So we are left with this single integral e raised to power minus st e raised to power t dt. So we can write it as 0 to 1 e raised to power 1 minus s t dt. Now all of you know the integral of e raised to power 1 minus s is e raised to power 1 minus st upon 1 minus s limit 0 to 1. So now let us put the limit. So we will take it as, let us take this outside, minus 1 upon s minus 1. When you put here t equal to 1, you will get e raised to power 1 minus s, that is minus of s minus 1, and when you take it 0, e raised to power 0 is 1. So after calculation, the answer will be e raised to power 1 minus s minus 1 upon 1 minus s. So this is the Laplace transform of piecewise continuous functions. Hope you like the video. If you have not subscribed, then subscribe it today and click on bell icon so that you can get the latest notification. Thank you.